Good morning, students. In today's maths class, I am going to explain factor theorem. Before it, you learnt remainder theorem, how to find remainder by remainder theorem. This factor theorem is also similar to remainder theorem, means there is some similarity because factor which we get factor and which is not a factor of any polynomial, that's something based on the division of polynomials. So what is the statement of factor theorem? If px is a polynomial of degree greater than or equal to 1, px is any polynomial whose degree is greater than or equal to 1, means its degree can be 1 or greater than 1, and a is any real number, then x minus a is a factor of px. If polynomial px and x minus a is a factor of px, when it will be a factor of px? If p of a is equals to 0. It means if we substitute a at the place of x in polynomial, then if we get pa is equals to 0, what we will say? X minus a is a factor of px. And second thing, if p of a is equals to 0, it means x minus a is a factor of px. अगर ये फैक्टर है तो पोलिनोमियल की वैल्यू a पर 0 होगी, और अगर वो फैक्टर कब होगा? अगर p of a 0 हो. If p of a is equals to 0, then x minus a is a factor of px. And if x minus a is a factor of px, तो p of a को क्या होना पड़ेगा? 0. अगर इसकी वैल्यू 0 आए तो इट मीन्स वो क्या है? इसका फैक्टर. अगर ये वैल्यू 0 है तो इट मीन्स x माइनस ए उसका क्या होगा? फैक्टर. बट अगर x माइनस ए फैक्टर है px का, तो इट मीन्स p of a इज इक्वल्स टू क्या होना पड़ेगा? 0. Let's we read statement of remainder theorem also, then I explain. If px is a polynomial of degree greater than or equal to 1 and a is a real number. So this is same thing. Px is a polynomial of degree greater than or equal to 1 and a is a real number. If px is divided by polynomial x minus a, then the remainder is pa. If px is divided by x minus a, then remainder is pa. तो हम यहाँ पर रिमाइंडर की बात कर रहे थे. रिमाइंडर जो है वो किसके इक्वल होगा? pa होगा. That means value of polynomial at a point, value of polynomial at 0 of the divisor. जो डिवाइजर है उसकी 0 फाइंड आउट करने के बाद जब हम पोलिनोमियल में पुट करेंगे तो वो वैल्यू आपके पास क्या होगी? रिमाइंडर. बट नाउ here it is given that if p of a is equals to 0, that means we can say remainder is equals to 0, then x minus a is a factor of px. मीन्स यही है, यहाँ रिमाइंडर pa था. अगर रिमाइंडर किसी केस में 0 आ जाता है तो उस डिवाइजर को क्या होना पड़ेगा? फैक्टर. और अगर वो फैक्टर है तो रिमाइंडर को क्या आना पड़ेगा? 0. Let me explain it by one example. Suppose if we divide 18 by 2, then what we get? 2 9s are 18. What is the remainder? 0. Now, what is the factorization of 18? We can write 2 multiplied by 9. We can write 18 is equals to 2 multiplied by 9. That means if we are getting remainder 0, then 2 and 9 both are its factor. If remainder is 0, then this divisor is a factor of this number. Now, if we divide 19 by 2, then 2 9s are 18. What is the remainder? 1. Now, what is the factorization of 19? There is no other factor of 19. 19 into 1. It means if you are not getting remainder 0, then this divisor is not a factor of this number. Okay. If the If we divide 19 by 2, we are getting remainder 1. When we are getting remainder 1, then we are not getting this divisor as a factor of this number. बट अगर रिमाइंडर 0 था तो डिवाइजर जो है वो उस नंबर का क्या आ रहा था, एक फैक्टर आ रहा था. तो वही तो यहाँ कहा गया है, x माइनस a इज अ फैक्टर ऑफ px if p of a is equals to 0. It means if we find remainder by remainder theorem, then this x minus a will be a factor of px. Let's take one example of polynomial. We have one polynomial px that is equals to x cube minus 4x. Suppose. Okay, x cube minus 4x. Can we factorize this polynomial? How we can factorize? We can take x common. What will be left? X square minus 4. We can factorize it more. X square 4 we can write as 2 square. So now what you will get? X a square minus b square. We can use identity x minus 2x plus 2 because a square minus b square that is equals to a minus b, a plus b. This identity is learned by you in 8th standard. So we have used that identity a square minus b square, a minus b into a plus b. So this is the factorization of px. Now you can check if we find what we want to say. We say that px is equals to x cube minus 4x. And we want to check x minus 2 is a factor of px or not. Check x minus 2 is a factor of px or not. Then how we will check it is a factor of px or not? Find 0 of this factor. Put x minus 2 is equals to 0. Then what will be the value of x? That will be equals to 2. So x is equals to 2. Put x value in this polynomial. That means as you were finding yesterday remainder by remainder theorem of polynomials, you have to find remainder. If you will get remainder 0, then it will be a factor. Otherwise, it is not a factor. As I told you in this example, if you are getting remainder 0, then this divisor is a factor. That means anyone, if it is asked, that will be a factor. Otherwise, not a factor. But if you are not getting remainder not 0, you are getting remainder here 1, then that is not a factor of this number. Similarly here. So we want to check x minus 2 is a factor of px or not. So x minus 2 put 0, we will get x is equals to 2. Then what will be the value of polynomial at 2? P2, it will be 2 cube minus 4 into 2. Put x value in it. So what is 2 cube? That is equals to 8 and 4 2s are 8. So 8 minus 8 is equals to 0. It means we are getting P2 is equals to 0. If P2 is equals to 0, then what we will say? Therefore, x minus 2 is a factor of Px. Only this you have to check that any polynomial is a factor of other polynomial or not. If you get remainder 0, then it is a factor of that polynomial. Otherwise, it is not a factor of that polynomial. This is only for your verification. If you are factorizing this polynomial, you can check x minus 2 is a factor of this polynomial. And this thing we can show by this factor theorem. If you get remainder is equals to 0, then this x minus 2 is a factor of px. What is the difference now between factor theorem and remainder theorem? From remainder theorem, you were doing only this thing. If px is divided by this polynomial, then remainder is value of polynomial at 2. and here you will also get remainder. But here, to be a factor of this polynomial, this remainder must be 0. As here you are getting remainder 0, so that's why this is a factor of px. Let's we take one more example. Yes, this is one question of your exercise. X cube minus x square minus 2 plus root 2 into x plus root 2. This is given a polynomial. You want to check x plus 1 is a factor of this polynomial or not. Let me show you statement of this sum in your exercise. Determine which of the following polynomials has x plus 1 a factor. These are given 4 polynomials. You have to check which of the following polynomials has x plus 1 a factor. It means इनमें से किन polynomial का x plus 1 एक factor है और किनका नहीं है. So how you will check? Firstly, you will find 0 of this factor. After putting that 0 in this polynomial, if you get remainder 0, then it will be a factor, otherwise not a factor. So let's we do in that same way. So we want to check x plus 1 is a factor. So we will find 0 of x plus 1. So let's we find, firstly let's we suppose that it as let px is equals to this. So what will be 0 of px? 0 of px not 0 of x plus 1 is x plus 1 is equals to 0. So what about x minus 1? Put x is equals to minus 1 here. What we will get? P of minus 1. It means it will be minus 1 whole cube minus of minus 1 square minus of 2 plus root 2. Don't put here minus 1 directly in this way. It means this term and this term is separate. But 2 plus root 2 into x, these are in multiplication. So in multiplication, so that's why put that minus 1 in bracket. Okay, take care of this thing. Don't put minus 1 as it is, because if you will put as it is, so that will be different term of this. But these 2 plus root 2 and x are in multiplication. So put minus 1 in bracket. And after that solve it and plus root 2 as it is. Minus 1 whole cube, negative sign odd power, negative minus. Negative sign even power, minus 1 whole square, it will be 1. Now this minus sign as it is. This 2 plus root 2 into minus 1, these are in multiplication. So 2 into minus 1, minus 2. Root 2 into minus 1, minus root 2. Plus root 2. Okay, so let's say solve it. Minus 1 minus 1. Outside of bracket there is minus sign, so sign will be changed when you will open bracket. Minus into minus, it will become plus 2. Minus root 2 will also become plus root 2, and this is also plus root 2. So minus 1 minus 1 minus 2 plus 2 root 2 plus root 2. It will be 2 root 2, because we can add like terms. Root 2 plus root 2, you know, it will be 2 root 2. Minus 2 plus 2, it will be cancelled. So we will be left with 2 root 2. So what we are getting remainder here? Not equals to 0. So because P of minus 1 is 2 root 2, that is not equals to 0. So therefore what we will write? X plus 1 is not a factor of px. Okay, so in this way you have to solve. Similarly, as you were doing in yesterday or day before yesterday homework, find 0 of divisor and put that 0 in polynomial. That gives you remainder. If you get remainder is equals to 0, then that polynomial will be a factor of px. Otherwise, it is not a factor of px. Okay. And similar to it, there is a second sum. Let me show you statement. Use the factor theorem to determine whether gx is a factor of px in each of the following case. So factor theorem used to check gx is a factor of px in each of the following case. That means gx is one polynomial and px is another polynomial. You have to check. Let me show you. you have given px and this is a gx. You have to check gx is a factor of px or not. So find 0 of gx, that means find 0 of these polynomials. If you get this polynomial value at 0 of gx is equals to 0, then it will be a factor, otherwise not a factor. So first and second sum are same. So for today's homework you have to complete first and second sum. Okay, and before doing sums, before doing any new topic, you can read basics of that topic from your book, then it will be more clear to you. And after that, if you feel any problem, then you can discuss that problem, you can share your problem in discussion group. Okay, bye bye, happy learning.